go through a little bit of a review with you guys. We're going to start with naming compounds as well as a little bit of formula writing. So this is something that you guys did in grade 10. And you guys did a lot of this in grade 10. So the types of compounds that you normally have are basically chemical compounds that are made from two different types of atoms. So let me get set up here. Okay, so when you're looking at a compound, it's usually made up of atoms. So you have two particular types of atoms that you can use. You have metal atoms and you have non-metal atoms. Now, the metal ones are generally on the left side of the periodic table. So it's usually some kind of metal. So let's say metal atoms plus nonmetals. These two combinations will generally give you something called an ionic compound. Okay. Ionic compounds basically have positive charges and negative charges. The metal generally has a positive charge. Nonmetals tend to have negative charges. This just means that metals like to give away their electrons, which are negative. So if they give them away, they become more positive. Therefore, they have a positive charge. Nonmetals are atoms that like to gain or take away electrons from others and then keep them for themselves. So that's why they actually have a negative charge. So when you have a metal that wants to give away an electron and you have a nonmetal that wants to keep the electron, sometimes they will form a bond. Okay, and that bond will help them form an ionic compound. What we want to know is how to name ionic compounds. So let's start with these three examples here. So the first one, we have NaCl. Okay, you have to identify the full name of the first atom. So in this case, Na is sodium. So I write down sodium. The second atom is the nonmetal. Okay. The nonmetal is called chlorine. But the name of this compound isn't sodium chlorine, it's sodium chloride. So we always have to drop the ending of that nonmetal name and replace it with IDE. So this becomes sodium chloride. Okay. So this is one standard example of an ionic compound and how we name it. The full name of the metal, and then you take the root name of the nonmetal, which in this case is chlorine, and then you drop the the INE ending and replace it with IDE. So it's chloride. So the root is chlor. So if we take that same idea and we apply it to something like Cu. Cu is copper. But copper is special because it's a transition metal. It doesn't have just one charge like sodium does. Okay? Copper can have either a +1 charge or a +2 charge. And depending on what type of copper this is, we have to make sure that we name it properly too. So one of the things that we can figure out from all of this is that from our previous example, Na and Cl both have single charges of +1 and -1. And the way that we kind of figure that out is by looking at our periodic table. Sodium is found in the first family, all those atoms in the first family, or the first column, will have a +1 charge. Chlorine is found in the 7th family. They actually gain 1 negative charge because they're 1 charge away from becoming a noble gas, okay, which is at the very end of the periodic table. So if you accept the fact that chlorine has a -1 charge, okay, and you look at our compound here, it's CuCl2, which means you have 2 chlorine atoms. But why would you have 2 chlorine atoms for just 1 copper? Okay, so let's look at it this way. One of those chlorine atoms is basically a -1 charge, but you have 2 of them, right? So 2 chlorines means the chlorines have an overall charge of -2, but you only have 1 copper. So which one would make more sense? Would it make sense that the copper only has a +1 charge, or should the copper have a +2 charge? Well, if you said that the copper has a +2 charge, then you only need 1 of them, okay, to balance out the 2 chlorines. So this copper here must be the copper that has 2+ charges, okay, because this 2+ will cancel out the negative effects of the -2. So if this is true, and that our copper has a +2 charge, we have to identify that in the name. So this is going to be copper. So again, full name of your atom. But to make sure that everyone knows that this is copper 2 and not copper with a 1+ charge, we write in the Roman numeral 2 followed by chloride. So this is now copper 2 chloride, okay, not copper 1. Now, the only other type of ionic compound that you might find is a compound that contains a complex ion. So in the third example, we have MgSO4. Mg is the metal. So you'll notice that the metals always comes first. So if you find out what atom is that first substance, that's your metal. Okay. Now in this case here, S and O, sulfur and oxygen, those are both nonmetals, okay, because they're on the the right side of the staircase on your periodic table. And last year, you would have gone through how to identify which ones are metals and nonmetals by looking at the position on the periodic table. So since both S and O are nonmetals, we actually group them together. Okay, these guys are actually called polyatomic or complex ions. Okay, it's basically an ion that's made up of more than one atom. Okay. So far, chlorine and copper and sodium, all by themselves are just single ions. But sometimes you have a cluster of them together. So in this case, it's SO4. And SO4 is called sulfate. Okay. If you're not sure of the name, on the back side of your periodic table, there is a list of all your complex ions. So all you have to do is go on that list and look for SO4, and it'll actually tell you the name. Now, the name of Mg is basically magnesium. So again, full name of the metal. But then, in order to write in the SO4 part, all we have to do is write in the word sulfate. Okay? So whatever the ending is for that complex ion, or whatever the name of that complex ion, that becomes the secondary name for this compound. So we don't have to alter its ending. It's fine the way it is. Okay? So magnesium sulfate refers to MgSO4. If you were to try and look for a compound called magnesium sulfide, okay, that's different. Sulfide refers to just a single sulfur by itself. Okay, so that's why we don't drop the ending for sulfate and turn sulfate into sulfide, because that is actually something different. So whenever you see the complex ions, just use the full name of the complex ion. Okay? Those are basically your ionic compounds. Okay? So to go in the opposite direction, let's say you are given the name of a substance, but now you want to write out the formula. That's easy as well. So all you have to do is actually have your periodic table handy. So in this case here, your first one is called iron 2 bromide. Well, iron is your metal. So it's going to be the first element that you write down. And iron, its symbol is Fe. Okay. Now, the 2 here tells me that this iron atom has a 2 plus charge. Okay. Bromide refers to bromine. So you look for bromine on your periodic table and find its symbol. It happens to be Br. Okay. Now, Br is in the same family as chlorine. And since chlorine has a -1 charge, bromine will also have a 1 minus charge. Okay. So right now, the charges are not balanced. You have 2 positive charges and 1 negative charge. So in order for it to be balanced, you will actually need a second bromine. So you're going to need 2 bromines for every 1 iron. So we put a subscript 2. Okay. The subscript 2 will tell us that we have 2 bromine atoms. Okay. We normally don't write in the 1 for iron, so we can just leave it. So your final formula for this is just FeBr2. Okay. Let's look at one that has a complex ion. Here you have lithium carbonate. So again, lithium is Li. It's in the first family. So that tells me the charge on lithium is a 1 plus, or +1. It has a single positive charge. Now, carbonate, you're going to have to look not on the periodic table, but on the other side, under the complex ions. So carbonate, if you find the name, you'll realize that the symbol for carbonate is CO3. Okay? The charge is also given on that table. And the charge happens to be -2, or 2 negative. So your nonmetals give you a charge of -2. Your positive ions, in this case Li, is +1. Well, again, they're not balanced. But this time around, you need 2 lithiums and just 1 CO3. So to show that you have 2 lithiums, you just put a 2 as a subscript next to lithium. So the formula for this is now Li2CO3. So that would be the formula for lithium carbonate. So in a nutshell, this is basically how we name ionic compounds. The next video that I have set up will go through how you name molecular compounds.